Okay, so again, when you present an answer, your answer should look right and it should be kind of easy to see. And in most cases, even those of you who it was not clear and was very hard for me to follow through. So some of you looked at the logic, but your job is not just get the right answer, not the right correct procedure, but also make things really clear. Okay, so here first of all, here's the list. Here's the piecewise different function I gave you on the quiz. And by the way, I still don't know how to write that piecewise function like this way on Canvas. So I wrote it fx with this and fx with that, fx with that, because I couldn't figure out how to write a parenthesis there anyway. But I know that's the way I could. That's the only way I could express the piecewise different function. So that's what I did. On this editor, of course, this is a different editor. This is the editor for math features, and so I could write it this way. Anyway, that's the piecewise different function. And now the question is find the m and n such that f is continuous. So first of all, when you do something like this, first of all, always make things very clear. So the first thing I'll write is, you know what? When the function is already continuous, except that x equals 0, x equals 1. Why is it so? Because when you look at these functions right here, this function and that function and that function right there, all three of them are continuous functions. That is on each of these intervals. But when you connect them, the continuous is not guaranteed. Therefore, this function f is already continuous everywhere, except you don't know whether it's continuous at x equals 0 or at x equals 1. At those 2 points are the only places or points where continuity is not guaranteed. So if you state that tells us, okay, so the function is already continuous at those points. You only need to worry about those 2 points, x equals 0 and x equals 1. Now, if the function is continuous x equals 1, how do you make the function continuous x equals 1? What you have to do is you have to find the function value, and then we have to find the left limit of the function x equals 0, which is this guy right here, and we have to find the right limit. And this was not made clear on many of your papers. And then, if the function continues x equals 1, and note that when x equals 1, we take the limit of x is approaching 1 plus, and then fx, and then this is what we get right here. See this guy right here? We need to have the limit x up to 1 plus. So those of you, many of you have this, I saw this one. The limit of this, the limit of what did I see? I saw this. The limit of this, then minus the 1 over cube of x, and then what? Minus 1. And then limit at x equals 1. If any of you have this, x equals 1, this is actually wrong. Because in this case, here what we have is the limit of f of x. And then if you want, and then for the f of x, if h is approaching, so when x is approaching 1 plus, then we can replace the f of x by this right here. Note that this function right here, only when x is bigger than 1. So when you have the limit of x equals to 1 here, I get this, but this is wrong. Because again, if you have the limit of f of x, and then x up to 1, then what is this expression? Can you simplify this expression? The question is, can you simplify this? This one you cannot simplify. This one you cannot simplify. You know why? You cannot simplify. Why? Because when x is less than 1, again, when x is less than 1 right here, we have to take this expression. When x is bigger than 1, then we take this expression. So when you have the expression like this, the only way to do it is to do this, and then you split this. And then to the linear limit, the limit of f of x, we have x equals to 1 minus. 1 minus here, and then the limit, the other one has limit as well. X equals to 1 plus. So when x up to 1 minus minus, which means that x is less than 1, then in this case, this fx right here can be replaced by the mx percent. This guy is not mx percent. Whereas this guy right here is now the square of x minus 1 or the square of x minus 1. If you just have this right here, this cannot be simplified. So we would have this guy right here. And the solution would be x approaching 1. I know, many of you
They're having fun.
Plus or minus equals something. And so, you know what? When it comes to math, your language must be super precise. We need super precise language here. Again, this is like English spelling. This is like writing an address. Writing an address. If one number is wrong, then it does not go to the right address. This is like what? This is like writing a program. If you have a programmer, yes, you know. One character is wrong, then it does not work. If you have a space somewhere, then it does not work. It's like in a when you visit a website and you have one spelling mistake, it does not go to the website. Math is like that too. You have one thing wrong, it does not really work. But so many of you just write line. Oh, just a typo, and you know what? And then we end up getting all these, and all these bits and pieces which are incorrect. Here. Typos. And what kind of mistake do you call it? Small mistake. Any mistake, any tiny mistake, any tiny mistake, or tiny mistakes are critical in math. Okay? Now, so many of you come to me and tell me this, ask me this. This is the only kind of mistake I made. This is a type of mistake I made, and then you took off 17 points. You know, many of you, few of you ask me this kind of question, and the answer is yes. You know what? If you make one type of mistake, be ready for 20-point deduction. All right, is that clear? I want to make this very clear. This is calculus now. X is not y, y is not x. If you somehow write the y like an x, and then the y becomes x again, and then things like this, like here we have square. One other kind of mistake I saw in this last test was this, square of x minus 1. And some of you, square of x minus 1 is this, and then you heard this as this. Are they the same or not the same? Are they the same or not the same? This is square of x minus 1. Is that the same as square of my x minus 1? No, they're not the same. You know what? Don't tell me that's a typo. It doesn't matter whether it's typo or not, but it's wrong. This is wrong. You know what? There's so many things like this. Limits like that. 0 plus 0 minus. Instead of f of x, you will be writing f of c. And then you will tell, I just wrote x instead of c. No. F of x is not f of c. Okay, so and then if you take the derivative, same thing. F comma c is not the same as f comma a. Don't make these kind of mistakes. You have to be super picky. Alright? Math is a very picky subject. But English, same as a programmer, same as writing an address. You know? Same anywhere. Because in bank, if you have extra zero, that's a huge amount of difference, right? Is that true? One character, so that the $100 is not the same as $1,000. The only difference is putting an extra zero. So in all fields, in all disciplines, one character, makes a big difference. And somehow in math, students think that that's not a big deal. But you know what? The penalty is still, and in this class, I just want to remind you, if you make one of those tiny mistakes, the penalties will be huge. Again, the mistakes will have an unfairly high penalty. And let me say this. And many of you will say, yeah, this is really unfair. You know what? That's how it will be in this class. A tiny mistake could be a 20-point deduction. All right, that's clear. So all I ask you is be careful. Just like any discipline, writing an address or a foreign language or an English spelling, you know what? In programming, in any discipline, you make one character mistake, the whole thing blows up. It's just nonsense. I think many of you, when you write math, you don't know what you're writing, and you don't know what it means, and therefore you can care less, right? But these penalties are very heavy. So if you give me a structure like this, I would really appreciate it. So let me just save this and then clear all this. So again, you know what, class? This is the kind of format I was looking for. If you give me a solution like this, it's very clear to see. We know exactly what's going on. And so once again, to make it continuous, what we need these three things. We need these three things. Like at 0, we need this guy, and this guy, and this guy. The three guys must be the same. And then at x plus 1, these guys must be the same. The function of value,
not really, but I figured you would because I got two purple Jesus.
They all must be the same. And of course, the important part of this problem, all the other limits are each, all the out of the 6 items, 5 items are very easy to find. 3 items won't work, as of course this guy here.
And then I knew that was going to happen. I was like, oh shit, we probably shouldn't have watched this so late. And then 7 was up, crawling around, and I had to get him, put him up, and then fell back asleep, and then my alarm went off. I was going to get up early, and I was exhausted by the time the alarm went off. I also had a hard time. Cosmo got this squishy mattress.
Some of you trunk qualify this until you start to do it. And you had a 2 there. You know what? If you had a 2 there,
I slept so
those of you had a 2 there, I don't know whether or not you type it out. That's a really bad mistake. That is really bad mistake. Okay? This is bad.
You have to give you sleep really good with Jesus. Don't be shy about taking the adult-sized doses. You gotta get through this.
This is deadly.
You
If I see that 2 there, you know what? You get a 0 in the 10 part. There's nothing else I can do. It's not that you don't give me a reason, and you don't follow through. And some of you had 6. Some of you had a 2 right there. And then when you come to find the limit here, it should be 4. 1 plus 2 plus 1 is 4, but you still have a 3 here. So you have this, and then when you consider you have a 3 here. That's really wrong. So in this fact, if you make a mistake, you should carry on to that mistake. That mistake should never go back to the original right answer. It's worse. Alright? So don't do that here. So once again, you know what, let me just clear this. So when you present a solution for a problem like this, I want a solution which kind of looks like this. Very easy to read, and I can see the whole thing I want. Look at that. If I see this, you know what? Just the format itself, you know what? If I see this kind of format, then even if some of your details are incorrect, I am more willing to give you more like almost full credit. So the whole thing has to look like this. So I can easily see, okay, so here this tells me what how much you understand. Okay, to figure out whether the function is equal to x or 0, that means you have to find this, and then you have to find this, and you have to find this. And it's very organized. So I call it like that. The function value of 0, what happens to the function from the left? The left from to 0, and this is right side x equals 0. Left side x equals 0, give a function value. So I name it this way, but you don't have to write these kind of things. Okay, this, you don't need it. But at least, this is what I'm saying here. The things have to be organized, easy to read, and now everything's clear. By the way, in this class, if your solution is very easy to understand, then even if you make a small mistake, I am willing to deduct far fewer points. Is that clear? In a very organized solution, if I see a mistake, the penalty for that mistake will go down significantly. So I was about to take 8 points off, but I look at a clear solution like this, okay, I'll take 2 points off. Because your writing is so clear and so easy to understand. Again, if your solution is easy to understand, your minor small mistake in any part of it, the weight of the mistake will go down significantly. Is that clear? So, I mean, not every one of you can write a solution like this, but something of this sort has to be super clear. So why is this clear? Because in this case, the reason why I call this clear is because no matter what part, and if you look at any part of it, you know immediately what that is. So the reason why this solution, I know, sorry, this is the solution I wrote down, but the reason why this solution would be a perfect solution is because it is so easy to see. If I look at any part of it, I know exactly. Let's say what I'm saying is this. What I'm saying is this, and then let's say if I look at this part, rather let's say I don't know where anywhere, I look at this part. Let's say for example, I look at this part, then I know exactly what this part is. It's the mix of this big argument. I know exactly what this is in the story of this whole thing. This is the whole thing here. And when I see this line, I know exactly what this is. I don't have to run through all this all the way here to understand what this line is. So that's why it's a good solution. Okay? Again, what I'm saying is when you write a solution, make it easy for the reader. Some of you, you have, I did give you 20 points, but you know what? It's really hard to understand, hard to write, hard to see what's going on. And plus, many of you have mistakes here and there, like all the mistakes, typo mistakes, this and that mistake, hard to follow. In this class, if you present a perfect answer like this, starting from this step, what I'm going to do is I am going to give you extra credit. If a problem is worth 20 points, you give a perfect solution, you do extra work to make it extra clear or whatever it is, I may give you extra points, all right? And then the penalty will be very harsh as the solution will have typos, mistakes, you know what, non-precise, expressions. Yeah, and by the way, let me also make another comment here. This is separate from here. Some of you have the limit. So let's say the limit is, you have to limit. To calculate this limit right here, what you did was, one of you did was this x, and then you write f of x. Write f of x, so fx is equal to f squared or whatever. Okay, so we have the expression, and then square of x minus 1. And then what you do is, you do this, and then what? And then x approaching what? X approaching 1 plus. So this guy is now approaching, you know what, let me write this down. Let me write down right there like this. And then you have a limit chart, a limit table. And then x goes to what? 1 plus. And then when this is, let's say, about 2, then you get a number. And then when you get a 1.1, then you get a number. And then when you have 1.000001, then you get a number. And then by the time here, by this time you could see this is 1.5 and 1.5. And then you make the conclusion that this must be 1.5. Now, will this kind of argument be acceptable in this class? Will I accept this argument? So the limit is 1.5, yes or no? Yeah, you know what? You can apply this kind of argument in your science class, in your physics class, in astronomy class, whatever class, in biology too. But in math, our main thing is logic. It has to logically fit. So in math, the logical requirement is much higher than the logical requirement required in physics. In chemistry and astronomy, it's superior than there, because in other subjects of physics or chemistry or astronomy, you know what? They have other things to worry. They're interested in solving the problem, solving the real problem. In math, however, it's a logical subject. It's a little bit different. So our concern is, does it logically work? And in this case, if we say that this is approaching 1.5 numerical like this, you know what? This will be accessible in any science class. In a math class, this will not be accepted. So this here, the limit here, even though it is correct, actually you cannot guarantee this. It's an estimate. There is no logical guarantee. Okay? But in math, over here, when you come to this point right here, this one is fairly understandable. At this point here, x approaching 1, it does become 1 plus 1 plus 1 over 1 plus 1 is 3 over 2. So here, there's no question, because this is a non-indeterminate form. Every indeterminate form must be converted to a non-indeterminate form before it gets to the answer. Okay, let me say this one more time. Every limit problem you have must be converted to non-indeterminate form, and then before it gets to the answer, unless you apply special rules. and special rules such as rule which we'll study soon. Okay, so this kind of argument, this argument does not apply here. Okay, limit from a chart and then estimating will not be accepted. So let me say again, this one, this method will not be accepted. This is not a mathematical method, okay? And same thing is graphing too. Never write the answer. Never any procedure justified by graphing. Also, some of you did this by graphing is not accepted. This class in math arguments must be mathematical, logical, strictly. There's no leeway here. Okay. All right. Any questions here? And please do not apply Lopez rule. All right? I know I like Lopez rule too, but you can use that when you go to Calc 2. Okay, right now in this class. Excuse me, 1 second. Okay, so I'm sorry. So basically, what I'm saying is, the language of math is very strict. You know what? Every little difference, a plus is not the same as minus. 1 plus is not the same as 1. When x is approaching 1, that's not the same as y is approaching 1. F of x is not f of 1. Okay? So there must be a logic to it. So be very, very careful with what you write. And by the way, what students don't know, let me tell you this. When students write a solution, they leave a lot of traces behind. When somebody commits a crime, the person leaves a lot of traces behind. All right? Unless the crime is a perfect crime. When students write an answer, students do not realize that they leave a lot of traces behind what they're doing. All right? And many times it is not a good thing. Sometimes I wish that they have not written anything. They're writing something. So if you want to write something useless, let me tell you, I think nothing is better than useless. Okay? I don't want to be too harsh here, but you know what? It's math. I just don't want to see these junky writing. Okay? Junky writing, a bunch of mistakes here and there, and typos, you know what? It's too much. By the way, in this class, by the time you make 2 mistakes, then you're completely out. At that point, I stop grading your problem. All right? 2 typo mistakes, 2 tiny mistakes. This is calculus now. I think you have to grow up mathematically. You need to give me a very clean, logical, very easy to understand solution. So this is one way you can make it really clear. A very clear, super clear, ultra clear solution with no mistakes whatsoever. Although we cannot avoid mistakes, but the overall argument should be very clear. Unclear argument, person hates those. Unclear argument or unjustified, procedure, it's not a good thing. So, this is calculus. You have to mathematically grow up. Okay? If it's elementary algebra, I can be more, I can be more generous. But when you're taking calculus 1, you have to mathematically grow up here. Okay? So anyway, so much on that. Let me see. Do I have one more paper I want to share? You know what? There's another file here. Let me see. Did I write that? Yeah, I see. Check your work. I just create another file like this. I know that I'm running out of time, but let me still, spend a little bit of time here. This is called check your work. PDF. This is a very simple rule. So what I ask you is this. This is a comment on checking your work. When I check your work, is it coming up? not coming up here. You know what? Let me just cancel this. Maybe I can open up that tomorrow. Now, what I like to do is let me continue. Let me get the argument here. What I like to do is this. How about what is the question here? Section 7 point. Section 2.3. Okay, so we have 2.3. There's a file called the 0723 common tangent.png. This is actually a note from my last semester. And let me now go over this one problem. Okay, so this is one problem here. So now here's the problem. And right now you don't know the problem here. So let me just explain to you what the problem is. So how about this? Let me basically explain the problem this to you. So this is equal to 1 second. This is x times x minus 2, and the other one is this. Okay, this right here. Okay, so to help you understand the problem, what I'll do is I'm going to do a new share. I'm going to open up a whiteboard. Example. This is a tangent line problem. Find the tangent line. Find the tangent line. Find the line. Find the line. Tangent to both. To both curves. Y is equal to x times x minus 2 and y is equal to minus x squared and then what? Plus 1. So let's look at a problem like this. So this is a problem. This is a common tangent line problem. So what we have is, first of all, we have, let me just draw the sketch here. Of course, you can always, sketch a perfect graph on your graphing calculator. But here, the big point is to understand. By the way, this problem right here can be done without the use of a graphing calculator. Again, if we do use a graphing calculator, the answer will not be accepted. Answer by what? By graphing calculator is not accepted. Why? Because there's a logical problem. That line you get from your graphing calculator, that will be an approximate line. It will not be the exact line. So many of you, when you write that line, it will not be the exact number anyway. You can estimate the line, however. How about you know what? By what? By graphing calculator? One can what? One can estimate the line. But you cannot get it. The line is not guaranteed. You can estimate. The graph will be an estimate. Okay? All right? Okay, so now let's first explain to what this is. Okay, though, this is a problem here. Y equals x times x minus 2. The graph looks like this. 2 here, and this is 1 here. And let's say the graph looks like this, roughly. This is just a sketch. This is to help us understand the problem, okay? Again, this graphing is not to get to the answer. The graph is going to help us to understand the problem. Okay, is that clear? I always stress this. Do you still need to graph? Well, I do recommend you. Graphs are always helpful. Graphs help us understand the question. You can also what? You can also check your answer. Check your answer by graphs, by estimation. So what are graphs good for? First of all, graphs are very helpful. They help us to understand the question. That's a very big plus. Second, what are graphs used for? Graphs are very good for checking your answer, checking by estimation. However, graphs by solution is not acceptable. Okay, you won't give this estimation, and even if it's very precise, logically it is still not clear. Logically, it is not justified. So anyway, here's the graph, and then what's the other graph? With the other equation, y equals minus x squared plus 1. Is it minus x squared plus 1? You know what? I don't think it's minus x squared. What was the line? I forgot the line. Let's say, you know what? I don't think it's this one. Let's say, you know what? It can, if you have minus x squared plus 1, is it minus 1? You know what? Again, sorry. I don't know what the problem was. Let me see. Is it minus x? Oh, it's minus x minus 1. Sorry. Now I see. So let me now rewrite this. So here what I'm going to write is, it's not y plus minus x squared plus, it's actually minus x in the what? Minus 1. So let me write this again. Minus here. It's a minus 1. Okay, so let me write this in red. So that's a correction. It's a minus 1. So the graph, how does the graph look like? The graph is going to look like this. Minus x squared minus 1. Yeah, it looks like the minus x is 1 here. Actually, a graph looks like this. Okay, like this. Okay, so now, the question. What is the question? Now, the question is to find a tangent line. And find a line tangent to something. So if a line is tangent to something, that's a tangent line. Except the line we're looking for is a line with a tangent to both lines. We call this a common tangent line. Common tangent to two curves, to the two curves. This is a common problem. It is a common tangent line problem. Okay, so now here we have two curves here. Now what is the line we're looking for? We're looking for a line, all the tangent lines which are common to both curves. So what kind of a line are we looking for? The line we're looking for is a kind like this. It looks like that will be should I write this in red? Yeah, let me draw this in red. Looks like that line, that kind of line right there. Yeah, that's it's not precise. How about let me write a line like this? And that line looks like it's a common tangent line to both lines. And then do you think we are going to have a tangent line over here? Well, we don't know. Now, are we sure that we'll get two such lines? We don't know. We don't know. So I'm going to put a question mark here. We don't know. Are we going to have more than two lines? Yeah, we don't know. Don't know. But we don't have to know. When you graph these here, what is the purpose of the graph? The purpose of the graph is to help us understand the question. So now we get the idea what's going on here. That's what now we understand what's going on, and now we can now start the problem. Whenever you have a math problem like this, I recommend to graph this and understand what the problem is. Unless you understand the problem already, then you don't need the graphs. Yeah, you don't need the graphs then. However, answer by graphing calculator is not acceptable in any way. So don't try to get the answer by using the graphing calculator. It is not accepted. Logically, it's not clear mathematically. Again, mathematics has a high logic standards here. Very high, much higher than any other science. More logic than physics, or astronomy, or biology, or chemistry. All those other disciplines, they have other concerns. So if you take chemistry, they're interested in chemicals, and then they have to know which chemicals where, and then what chemical is more efficient. I don't know, but they have other concerns. So that is their concern. So their major concern is not accuracy of the not the exactness of number. So exactness of number is a major concern in math, but it is not a major concern in other sciences. That's it. So the focus is different. Every subject is different. Okay. So that's why if you take econ and if you take business, then you don't have to. You can estimate the money. If it's like $2,510, then just say $2,000 or $2,500. But you don't have to go by all the cents and everything. They don't have to mention the cents because it's not the accuracy. It's what? It's the focus. All other disciplines, they have different. So now let me now erase this here. So now let's save this, and now let me clear this. And now what I'll do is I'm now going to go back, and now let's see what we have here. File, and now am I sharing the file here? Am I sharing the file? No. Now I'm not sharing. Now let's look at this. Okay, so now we get to the problem here. So now let's see what we have here. find the line tangent to both y equals x times x minus 2 and y equals minus x squared minus 1. Okay, so that is now the question. Now, how do you do this problem here? Well, now let me present you how you're supposed to do the problem, okay? Okay, so first we have 2 points here. We have 2 curves. We have y equals equation 1, y equals x times x minus 2, which is x squared minus 2x. And then we have another curve here, where it's g of x. Oh, g of x is this guy. Well, I didn't even write this guy. Number 2, y is equal to the here. Y is equal to, y is equal to what? Y is equal to, y, oh, what is this? So, sorry, let me just take this back. So what we have is, here we have y is equal to, y is equal to minus x squared, y equals x squared, and then y equals x squared, and then minus, minus 1. So this is, well, I don't know what this 2, what is this 2 doing here? I don't know. But anyway, is this the curve right here? And this is what I mean by g of x, our problem, okay? So now, let's look at this. We have the equation, f of x, y, this is f of x is x squared minus 2. And so now, the first thing is, why don't we now try to get the tangent line to this first function right here? Tangent line to the first function is this guy. F prime of x is now what? F prime of x is 2a minus 2. So now what is the tangent line at a comma f of a? Tangent to the function y equals f of x. And it turns out that it is this guy right here. The bottom right here, this is what you see. So when you simplify, this is what you see. And that is actually a square. This is actually square here. So this is a square. Let me write a square. This is a square. A square. Okay, this is a 2a minus 2x and then minus a square. All right? When you simplify that, you get minus a square. Minus a square. So this is the line. This is a tangent line to the first curve at a comma f of a. Now, let's get to the next step. Now this is equation 2. Oh, I didn't write equation 2 here. Equation 2 is now y is equal to what? Y is equal to minus x squared and then minus 1. That's equation 2, not x2. Equation 2. So, and then now we take the derivative, we get the g prime of x is 2x. So now we want to find the tangent line at b comma g of b. So the tangent line at b comma g of b. And what is g of b? G of b is, of course, b comma minus b squared minus 1, because that's our g of x right here. Now, at b, what happens here? The slope is 2b. So we end up getting this line right here. So y is equal to this. Ultimately, we get the line equation right here. So this is a tangent line to the second curve at b comma g of b. Does anybody follow me here? Does everybody follow me? Follow what I've done so far?
Yes.
Basically, we have a curve here, and we have we have a curve here, and we have a curve here. And we're trying to find the common tangent line. We're trying to find this line right here. So right now, at first step, what we have done is we have found a tangent line to this the first curve. And this point is a comma f of a, and then now, in here, the second part of it, I now figured out, I found the equation to the tangent line, the equation of tangent line to the second curve at b comma g of b, and so we get this line. Now what do we want? We are looking for a common tangent line. So we want to see when these two lines will be equal. So we got these two lines here. Will these two lines ever be equal? So now the question is this. The general question is, if you have a line equation like this, let's say we have a line equation, let's say y is equal to, and let me write this in blue. If you have a line equation which says, how about let's say mx and then plus n, and then you have one other line equation, y is equal to, let's say, px and then plus q, like this. How how do you know whether these two lines are the same line or not? Well, what is the condition that the two lines be the same? So how can you make the two lines equal? When will the two lines be the same line? What will be the condition? If you have two lines, one line is y equals mx plus n, and then the other line is y equals px plus q, when will the two lines be the same line? Can you tell me the condition in terms of m and n and p and q? So when will the two lines be the same? There's only one way. In order for the two lines to be the same line, there's only one condition. There's only one condition. What is that? Well, actually two conditions, but I mean one set of conditions, and if that's the only set of conditions we must have. Okay? So, what to be the same line? M must equal what? N and P. M must equal P, and N must equal what? Q. I don't know. Is this too hard? In order for these two lines to be the same, M must equal P and N must equal Q. So that's the only way. If we need both of these conditions, we must have both of these, not one. Okay, so now in this case, in order for that to hold, in order for these to be the same line, so now, actually I wrote it down right here. I wrote the same thing again. So I can actually erase all this. Okay, erase all this. I wrote it right here. And so what did I write here? It says here, if line AY equals AX plus B is the same line as Y plus CX plus D, then what? Then what? Then A equals C and B equals D. So that's the general principle. And this is actually for non-vertical lines. If you get into a vertical line, then you just have to compare them. Your vertical lines have a special line form, so we will have a separate form, but it will actually be easier. Okay, so in this case, if these two lines must be the same, what is it that we need? We need this. 2a minus 2 must equal minus 2b. The 2a minus 2 is right here, and is equal to what? Minus b is right here. So the coefficient of x must be the same. And then what? And then the constant terms must be the same. Minus a squared minus a squared must equal b squared minus 1. So we have these two equations right here. Now from the first equation, you get a equals minus b plus b, a equals minus b plus 1, and you substitute, and then I get the answer. Now here in this case, you have two possibilities. When you solve this equation, you get two. So a, b equals 1, 0, and b equals 1. So what are the two tangent lines? When you get the tangent line, what are the tangent line equations? The tangent line equation is this guy right here. This is the tangent line equation right here in B, which is same as the tangent line equation A, this guy right here. But in this case, we have the values for B. When you plug in these values here, we get two lines. Y equals negative 1 is one line, and y equals negative 2x is the other line. Any questions here? Any questions here? Stop. Any questions? Oh, it's already 10:50. I guess I have to stop here. Any questions here, class? Any questions on this problem?
No.
Just a question. What would you call this? Okay, I see.
Yeah. So you know what? Right now the time is up, so I can continue. But let me tell you this. Tomorrow we'll be starting section 2.4, which will be trig. Section 2.4 is trig, which this is our next section. So therefore, what I'll do is this. Please review what? Review your trig. Trigonometry, okay, all right? Now, we cannot postpone this year. The trigonometry must be reviewed. Now, in this section 2.4, we are now going to start the calculus of trigonometry. Therefore, your calculus, your trigonometry must be ready to go. So I'm not going to make it too burden here, but you have to, nonetheless, review your trigonometry. So please review. And by the way, my plan was to give you the test on Friday, but this Friday, at this pace, is impossible. So for now, I'm planning to give you the test on Monday next year, hopefully. Is Monday a holiday again? No, Monday is not a holiday. Okay, so hopefully you'll have the test on Monday. Okay, all of you have a good day, and good day, and I will see you. I will meet you tomorrow. Bye, everyone.
Thank you.
Professor,
And bye.
can I ask you the question?